Music has been a huge part of human culture for thousands and thousands of years. It's been used for entertainment, for storytelling, for religious ceremonies, and has been a part of human culture since its inception. Whilst we can make our own music through singing and clapping, we've been using objects to produce sounds for just as long. In ancient times, large stones would be used as instruments during religious ceremonies to represent animals, and over time instruments have become more and more complex, including flutes made of ivory from over 35,000 years ago. Also throughout history, materials science has been a rate-limiting step in the worlds of innovation and production, and as our knowledge of materials science improved, we were able to produce and manufacture more and more exciting products. New instruments have become possible due to the innovations in material science, such as plastic brass instruments like this cornet. With polymer injection moulding and forming, we have been able to create all of these new objects and instruments. Flutes from hundreds of years ago were carved into wood and have since become a marvel of metal craftsmanship. But this brings up an interesting question. Do materials make a difference? And the answer is, that depends. There are two main groups of instruments in what's called the Schaffner system. Vibrating air instruments such as brass and woodwind instruments including the clarinet, the saxophone and the euphonium. And then there are vibrating solid instruments such as percussion instruments and string instruments like the cello, piano and drum kit. The key distinction, as you imagine, is what is vibrating to produce the sound. Yes, air may be used to amplify the sound, such as that in marimbas and drum kits, but they're not the original source of the vibrations and the sound that we hear. For vibrating air instruments, it doesn't make a huge amount of difference depending on what material you use. So long as the vibrating column of air is kept in the right shape and in the right geometry, the sound will remain mostly the same. Many flautists care greatly about gold-plated or wooden lip joints, and brass players will swear by specific metal platings for their instruments, but in reality, these don't make much of a difference. For vibrating solid instruments, on the other hand, the intrinsic properties of the material can make a huge difference to the sound that it produces. One really interesting intersection between materials science and musical instruments is the steel drum. Whilst the choice of material is very simple for a steel drum, as it's in the name, the processing and the production behind that material can affect the properties at a microscopic level. Steel drums are produced by cutting up and shaping steel oil drums, and when these are in the correct shape, they are heat treated and need to be tuned. Tuning is the process of altering an instrument so that the notes that it produces are at the correct frequency, or pitch as musicians would say. We can do this by changing the geometry of the instrument, or we can do this by changing the properties of the material, such as the tension that a string is under. Steel drums are tuned by gently tapping with a hammer along the playing surface. This thins the metal and also introduces microscopic defects known as dislocations. Dislocations are a type of crystallographic defect in materials, meaning that they change the way that the atoms are arranged in the crystalline structure. In the case of a dislocation, this is where there is an abrupt change in the arrangement of the atoms, often in the form of what's referred to as an extra plane of atoms. As the steel is hammered, this generates more and more dislocations, which can result in changes to the mechanical properties of the steel through a process called work hardening. As more and more dislocations cause the steel to become harder, and the steel becomes thinner due to the hammering, this increases the resonant frequency of the steel at that point on the drum. By carefully tuning each portion of the playing surface of the steel drum, you can play anything you want. That's one amazing and subtle way that material science comes into play with musical instruments. To find out more information about material science, visit the Discover Materials website. Thanks for listening.